All right, hello everyone, and welcome to today's core developer meeting number 64. If you're in the US, it's 4th of July edition, so there should be some firework noises in the background. Um, if you're not in America, I don't know what else major's going on, so sorry for my ignorance.
Friday. It's the best day of the week.
Ah, okay, it is Friday. It's, yeah, middle of the night Friday here, so I guess I didn't register it. But yeah, it is the end of the week. Let's go ahead and review the previous decisions made and action items. All right, so we've accepted EIP 2024 and EIP 1702 into Istanbul, and we're shifting the time of the core dev meetings by 8 hours every meeting to better accommodate time zones. Um, as far as the actions required, one of the items was 62.2 to have an in-depth discussion on how EIP 663 can be improved. Um, did that? Which EIP was that again? Let me look that up. I think that's the swap and dupe instructions,
Yeah,
right?
yeah, it'd be
Okay,
really good. I think we should try to whenever we say like each 1884, we try to say what the content, what the title is, if possible. For people following along on phone, it's very difficult otherwise.
got it. I'll make sure to do that. So for EAP 663, unlimited swap and dupe instructions, I know last call we had a lot of discussion about that. Was there any further discussion after the meeting? Hmm. Okay. We'll just skip that one then. Sorry if I delayed for a while. I was also looking to see someone saying the live stream isn't working or it's only showing music. It looks fine to me. Next, perform a full benchmark of EIP 1108. That's reduce Alt BN 128 precompile gas cost. Um, I think we have some people in here who can speak on that, right? That one's the elliptic curve arithmetic precompile that's currently overpriced. We wanted to get some benchmarking done on that. I'm not sure who was
Yes, I,
actually
I
doing that
remember
or not.
they presented some benchmarks a couple of calls ago, and I asked them if because they only displayed the results that were, the exact same test vectors as, and not the complete test vectors, but only the exact same ones as I had found were the worst case, like what was it, 1.5 years ago. So I asked them if they had a full set somewhere, and they said, "Yeah, we'll run it again." That was not on the last call, so I don't know what's said last call though, but that's
Oh,
the
am I on the
example of it.
wrong summary? No, I'm on the right summary. I think the notes just might be a little bit wrong. Okay. The next is the discussion required between Jordy and Axic for EIP 1109 and EIP 2046. That's about reducing the gas cost for static calls made to precompiles versus having removing the call. Wait a second. Yeah, that tongue tied me. Axic, do you know what I'm talking about there?
Yeah, and there was some discussion on the Magicians Forum,
Perfect.
explaining both sides. But yeah, I don't think there was any agreement. It would be also nice for others to chime in.
Okay, can you post the link to the ETH Magicians forum the um, in the chat box in Zoom?
No, I cannot. I'm on the phone, but it's the discussion URL for.
Oh, okay.
I think it's a discussion URL for Jordies. That's where the discussion is.
You got it. I have that right here, actually, and I can paste it in. Yep. Cool, we both got to it. Thanks so much, Brett. Okay, so we'll just continue to discuss in that thread. So, and the reason that some of these action items might seem older are because they're from 2 calls ago, not 1 call ago, including that one because that was discussed 2 calls ago between Jordy and Axic, and there's been ongoing discussions since then on which one to do. So The next action item is 62.5, James Hancock to update the wiki and meta EIP 1962 with decisions around the EIPs. So James, what's the update on that?
Pretty up to date. The EIP still needs to be updated.
Okay. So is the wiki the most up-to-date source then?
Yes.
Okay. EIP 1283, this is action item 62.6. EIP 1283 requires a new EIP number and section discussing the difference between the original 1283 standard, which was removed for Constantinople, and this new EIP. James will reach out to the testing teams to understand the implementation difficulties. So 1283 is the one for net gas metering by way, and I think we talked last meeting about making a whole new EIP for that. Am I wrong there?
That was talked about at the meeting. There was a long discussion on Gitter over the last weekend. What's different with 1283 is it's the only EIP to be disabled ever. All we've ever done is we've added EIPs to a hard fork, and in Petersburg, we disabled it. So one thing that would satisfy me is if we had an extra section in the Istanbul, which rather than saying add this EIP, it's a different section that says re-enabled EIPs to make sure that it has, this is the first time we've done this. So I think it deserves a special call out. So if we did that, we wouldn't need an entirely new EIP number, because the argument also went to disable it. We should have made a new EIP that says undo that change. So if we updated the meta EIP to say reintroduce this EIP, I think that would satisfy all parties involved.
I wouldn't necessarily agree. The problem is that you have test networks that already applied that EIP. So essentially, you cannot really change the EIP content because it's already applied and already running on a testnet. Yes, it was reverted, but you still have 5 months worth of blocks which run that EIP.
Correct. And this EIP would be re-enabled with the other EIP that goes with it to provide one of the mitigations for what the problem was. So it would be re-enabled as written, and it would need to come with a separate EIP. However, if we want to rewrite it with EIP and grade it as one, I too would support a new EIP. Either solution is fine by me.
Yeah, I guess one point that you do have a really good point is that probably it's easier to understand the EIP if you just say that, okay, this is the previous EIP plus this 5 lines of diff, instead of a huge EIP that everyone has to dissect to find the differences. So yeah, that's a good point.
I think like I still don't think like we should create a new EIP. The reason we had discussed on Gitter is that because we actually didn't change anything in 1283, and 7006 is an entirely new EIP that we can apply on top of 1283. Like this is just documentation process, but creating a new EIP for me, it just feels like a lot of confusions rather than clearing things up. And second, I think it's quite important that we have specification EIPs which defines how a change actually is, and also hard fork meta EIPs, which defines what goes in a hard fork. And so we should make sure that we should use the hard fork meta EIP to like have its functionality to actually define what goes into the hard fork, but not in the specification EIPs. Yeah, so I still don't think like we should create a new EIP number for this.
I think when we said to create a new IP, that also included there was this other EIP which changes store that if less than the stipend amount is left, then store wouldn't work. I don't remember what's the number of that, but that was proposed as one of the solutions for the problems with the net gas metering EIP. And when sorry, go ahead.
Sorry. So currently we have the 1283, like the original one, and we also have 7006. What 7006 does is it really doesn't change any calls in 1283. For implementation side, it's also the case. You don't change anything in 1283, but you just add a new, like entirely different calls in the top level of gas metering, saying if the gas is below this number, then we just fill the SS store opcode from that point. So it's like so the thing is, I think the 7006 is like an entirely, like it can, like from technical side it can be applied separately from 1283. Just we don't do that. So I think there's just no need to like get a new EIP.
So 1706 is the mitigation, and that is the number of the mitigation, and it requires 1283 right now.
Yeah, it's a mitigation.
So what I wanted to say is, back when it was suggested to write up a new IP, I think it was also suggested to consolidate the two into one. What I want to ask is that the IP still needed, or are you proposing to enable the NetGas metering through versioning?
Like right now, I would propose to enable the NetGas metering with version, enable both 1283 and 7006, because this is indeed like we avoid those backward capability issues, like at our best, and also it although satisfy the contract developers, like I think is still a frequently asked feature, and if those contracts are deployed with upgradability in mind, and they can take around existing contracts can use a proxy or something to take advantage of the net gas metering or through a new contract.
Sorry, I didn't understand.
Yeah, what I was saying is that I would propose to apply net gas metering with the conversion.
Right, so you would not retroactively apply it.
Yeah, no.
Is there still any point to having 1706?
It's like a small addition. I don't think it would hurt to include that. It just avoids some potential issues. Of course, if we apply net gas metering with the conversioning, we don't necessarily need 7006, but it's just it doesn't hurt, and it avoid potential issues.
And I think there's a real risk that some DApp developers will use old libraries and expose themselves to this accidentally, even with account versioning. So 1706 would be a good add in my opinion, but not required.
I agree here as well. 1706 sounds like a good way of documenting it and keeping it configured in the client.
Okay, so I'm hearing that we want 1706 in there if we're going to be including this EIP, which we're also leaning toward. Am I getting those vibes right?
So we're still at the review part of the previous meeting part of the call, right?
Yeah, we're just reviewing the previous decisions, and I mean, it can turn into conversation to make decisions since some of those action items want to result in a decision being made.
So yeah, so if we're having that discussion, as far as I don't care particularly either way. I see 1283 as a way that, I mean, calls are going to get cheaper, which means there are going to be more of them in the block and more state float, basically, even though they're not typically, they're not really related. But there seems to be a lot of people who wants this, and I'm a bit afraid that all these people who wants it because they're dApp developers and dApp users, they want it, but they want it on their existing contracts and their existing kind of infrastructure. And if we implement it but don't actually make it retroactive, then they'll just, yeah, then we miss the target, and we still get the heat of not having implemented it, um, but do all the work of having implemented it. So I'm a bit torn over that.
So I have comment. I actually have two comments. One is the right place to comment to IPs, or you
Yeah,
want
if
to
it's
go?
related to this
Okay, so
item, sure.
1706. So it looks trivial, but it's not if you have optimized gas counting. So the gas counter, it's not actually available all the time in the EVM. So it's much more complicated than it looks. So I'm not really a fan of it because it requires some additional complexity in the implementation of it. And about using account versioning. I mean, in general, account versioning is also not my favorite thing to apply, because that actually requires you to keep two different kind of EVM specs around all the time, because you can have two different, two versions of accounts in the same hard fork. So far we had this progression of hard forks. When you sync to the recent one, you don't actually need the previous revisions of EVM anymore, and you can even implement the client in a way that you fast sync to the top block and don't even implement the previous revision of EVM at all. And with account versioning, we're starting to add this need to keep different EVM revisions around all the time, because in any point in the future you can expect like at least two different account versions to be executed. So I understand it's useful for some EIPs which introduce really backward incompatible changes, but I would like to not to use it for EIPs that can be applied in a different way without actually bumping the account version.
Does anyone have a counter to that?
Well, first I have a question. First of all, Pavel, so if we want to go in the direction where it's possible to have more just-in-time compilation of contracts and some ahead of time look ahead, where you go a couple of instructions ahead and count gas and stuff like that, does the 1706 disable ester with gas left lower than calls type and cause a problem in those kinds of scenarios? Is that what you're saying?
Well, it's not like it cannot be implemented. It's a bit. It requires to store additional data, and yeah, it's similar to the gas instruction when you need exactly the gas counter at given execution point. But
Yeah,
it's
you need to actually
yeah.
execute.
So I need to like apply the same trickery to actually have this value at the. I would need to apply the same thing for a store. It's not like very complicated, but it's a bit more complex that it looks on the paper when you have only like additional check to do. And in general, like, well, I think it would be maybe more visible if actually the two of these were combined in the new one, because then we can see how actually complex the whole thing is. I mean, it's like, I think in the end, the net gas storing wasn't so trivial to do. There was some like a lot of different cases to check, and this adds another one that actually makes. I fear that like make reasoning about how the storage cost will work might make it even harder. But that's comment is only by intuition at this point. I'm not prepared to actually go deeper into that.
Okay. Do we have anyone to counter that or to do a strong, I guess, opposition to those statements at all?
I mean, I have reservations that we probably, I mean, it's not like if you have a EVM implementation, it's not really like you are like starting a fresh new EVM implementation for each hard fork. You just change a few feature flags. So I actually don't think that like apply EIPs for backward compatibility reason, even it is not an entirely new EVM would be a issue because it doesn't really like it doesn't really add much complexity in the EVM because we need those feature flags for most of the time anyway. So that's my counter probably.
Well, to counter the counter, however, so I do agree that extending the current EVMs is relatively cheap. So, I mean, we need to implement a new feature and just don't delete the old one, and then everything is done. But I guess the point Pavel was trying to make rather is that if you want to create a completely new EVM, for example, a completely new team wants to write an Ethereum client, then if we keep just always piling stuff on, but we need to support all the old stuff too, then we will end up in a situation where after a while, the barrier of entry to writing an EVM is so large that only the established players will be able to keep on hacking on their own stuff. And I think that's potentially, maybe currently the EVM is not that complicated, but it is getting more and more complicated. So it might be a legitimate thing to think over.
Yeah, and if I can add to that, so yeah, I would say that the EVM is already pretty damn complicated, and there are a lot of corner cases. And the more we add, the more things that we deprecate in old versions, but don't actually deprecate, but instead keep around, means that there will be more edge cases, and less people will remember all these old way that things work, and will lead to trickiness. That's not really a counter to versioning per se. It's more that a counter to what I heard from Pavel was that we should use, even if we have versioning, we should use it as little as possible, only when we really think it's required.
Yeah, and like I would also argue that because we are running Ethereum, like security is the actual main issue. So I would put backward capability to have higher priority compared with new teams implementing a completely new EVM for simplicity.
So, let me try to like clarify two things about that. So, what Martin said is correct. So, if there is a way to apply it without account versioning, I would prefer this way. And also, if there is another way to mitigate the security issue that was preventing it from being deployed on Constantinople, I would also prefer the other way. So if there is any other option than 1706, I would like to know and read about that. It mostly comes from the way I implement EVM in a bit different way, and like some of this decision are made upfront before the execution, and it just I won't go to the detail now, but it actually goes a bit against what I'm doing, and if there's a way to find a path forward that is more aligned with optimization I'm applying to EVM, I would prefer to just different options. But I think it should be enough for this discussion at this point.
So just to clarify, so 7006 is fixed for applying net gas metering without a conversioning. It was just we propose that we apply 7006 anyway, even with a conversioning to avoid any issues.
Okay, so on this, yeah, I get it, but I haven't answered to that. So if that's two options are available, I would prefer 1706 than account versioning used for NetStore.
So would I. Yeah. Dev developers seem positive about 1283, and we already decided once to implement it for everything, and only stopped it because of this reentrancy possibility. So I don't really see what changed. So I would prefer not to version it, but to protect it some other way.
I believe this is one of the few ones on the Gitter that people from outside of normally talking came into voice support, specifically for dApp developers. So just as a note.
Interesting. So,
Yeah,
it sounds like, are we leaning towards 1706? Yeah, Nick's coming in late. We can bench this until Nick gets on the call.
Yeah, I would vote to do that.
Let's do that. Yeah, and we should probably move on to a few other things in the agenda too. So we'll bench this one till Nick gets on the call in regards to 1706. So the next one is let's see. Engage with Ronan Sanford and Brian Eisenbach to discuss which EIP 1344, 1959, or 1965 should be implemented. They all have to do with chain code IDs. I think Ronan's here. Are you here, Ronan?
Yeah, I'm here. Yeah.
Awesome. Did you talk to Brian and others on the Magicians Forum about this, and is there any news?
Not any news. I was thinking we will wait because I can try to go to the next call because if I remember, Brian can only come on the following one. I don't know if
Brian isn't able to attend today.
Got it.
So I don't know if it's better. We can discuss a bit now, but I guess we should wait for.
Let's wait for Brian. Why not? That's a good idea. What were you saying, Martin?
Yeah, I would just like to hear the TLDR case for. So I know the 1344 in detail, and that's very trivial. I can't recall why there are two other ones, and what's the difference between 1959 and 1965?
Okay, yeah, this I can clarify actually. So 15, I forgot the number. Yeah, the 59 is 1959 was basically the first version I came up with, and then I realized 1965 was better in my opinion, but I left 1959 in case someone for some reason preferred it. So basically, I guess we could get rid of 1959 as
that's
part of
progress.
the discussion.
So 65 is the one where you have precompile and we ask it to check, hey, could you please check if this point in time is network ID X? Is that it?
Yeah, you basically specify both the chain ID and the block number.
And what particular use cases does that enable that you otherwise?
So it's basically a very specific case. It's basically to allow to bring fairness to every fork. So let's say I'm a minority fork, and then but I don't have a big following for some reason. But the idea is not that it will happen or not. It's the ability to this kind of community to form without having a disadvantage, and which is basically the idea that if you use 1344, you can't have an exact switch at which something is valid. You will have a gap of block number. I mean, I guess it was not clear. It's so let's say you create a message and you specify you specify the block number at which it was signed and the chain ID at which you want to use it. So if we don't consider the block number, then you will have replayability problem on yeah.
Yeah, so I'll just see if I've got this right and see what you think about it. In my opinion, 1344 solves a problem of if I want to sign a piece of data, then the contract can easily check, is this actually signed for me? Is it signed for this chain ID? Is it signed for mainnet or is it signed for Robston? I mean, we already solved it for transactions. What you're trying to do is also solve the problem that if we in the future want to change the chain ID, which has, I mean, that has never previously happened for mainnet or Robston or testnets. That's the kind of problem, the extended problem, which your EAPS tries to solve. Am I right about that?
Yeah, yes, exactly. I mean, 1344 have a way to solve it as well, but it's not complete, in my opinion. There is a case, basically, that's what I wanted to explain, a particular case where it will fail to properly.
So my 5 cents about that is that 1344 it's a very trivial solution to a pretty generic problem, whereas the other ones are a bit more complicated solutions to a lot more niche problem, and I would definitely prefer 1344.
Yeah, okay, makes sense. I mean, I guess where I was coming from was this idea of minority fork, because even though they are more complicated, for me, it's alone a decentralization part of that, like keeping the freedom to fork without having a disadvantage because you are a minority.
Just to add though, so currently if a minority fork, so for example, let's say somebody wants to fork off Ethereum and create a chain ID of, I don't know, 15, then you still have so the problem is that even if we implement the fancier solution on chain, the transactions won't have this capability. So I think from a practical perspective, it's cleaner to say that, well, transaction signing and data signing have the same capabilities versus saying that, yeah, data signing can do a tiny bit more, but it's a...
Yeah, it makes sense. Actually, I have a EIP in progress that I didn't put that will also solve it at the transaction level.
And isn't it also the case that in order to cater for this scenario where you have minority chains, the actual contracts need to take that into account, that, hey, maybe sometime in the future we wind up in a minority fork and then we need to use this particular check out the history kind of thing.
No, but that's the idea. If you use this EIP, then you don't need to worry. That's the whole point of this EIP. Well, with 1344, you most contract might actually use it as a hard-coded value, or they might use a caching mechanism which doesn't properly support it. So that's why this EIP is very specific function to allow contract creator to not care. We basically support them all the way.
Okay, yeah, I was going to make the argument that if you want to encode that functionality, then you could just add contract creation. You can save, store whatever you get from 3044 and then later compare it.
Yeah, but then you have a gap. So basically, that's you have a gap when you fork, because you will have to tell which block number exactly the switch happened.
Let's go ahead and table this till when Ronan can, or when Brian can get here. Since we've kind of had a taste of some of the arguments already, and we can continue this on magicians, so we can get on to other topics.
Can I just
But thanks
add
for,
one though?
yeah, Peter.
Just a quick memo. I just wanted to bring up a somewhat political argument against the more complex form. Is that, as basically from my understanding, the goal is to allow Ethereum chain to be split. I mean, to minority forks to be split off easily. And in all honesty, I'm not sure that that is something that we should promote. I mean, if somebody wishes to fork off Ethereum, yes, everything is open and they can do, but I don't really see the reason why we should put the developer effort and pay the price for somebody else to fork off. That's my political opinion on it.
Okay, yeah, for me, yeah, I mean, yeah, makes sense. For me, it's the opposite. I would say we want to keep as much freedom as possible so that the future of Ethereum will choose best path, whatever we think is best.
Okay. Thanks for that spicy political opinion, Peter. And next we have action item 62.8. EIP 1352 needs more work done to answer the question posed in the core dev meetings. And that one is called, sorry, Martin, I forgot to say the name of it, Restricted Address Range for Precompiles and System Contracts. This seemed easy at first, and then I think we needed to have more discussion in Eth Magicians because it had some weird edge cases. Is that right?
Yes, but I don't know what's the status. It's from AXIC, right?
Yeah. Do you have a status update, Axic? This is the restricted address range for pre-compiled systems contracts.
Yeah, I don't think we did any more than the edge cases raised on the forum. I think it would be nice for other stakeholders to also take a look, because it has a detailed discussion there. So it would be the right time to just read it and give an opinion.
So is there a summary of what the edge cases were, or are we expected to read the forum and distill it ourselves?
Well, this has been discussed in the... Okay, Martin, go ahead. You may be able to summarize it.
Yeah, so I raised some points that, for example, you could place a faucet in your Genesis at your testnet. You can place a faucet at a certain address, which is pure Solidity code. And if we implement this EAP, then all of a sudden that will be considered a precompile. And how should it be treated? For example, by Xcode hash and Xcode size, which normally return all zeros for precompiles. It's also a bit quirky if I mean, all clients have some kind of notion of precompiles where they are linking to actual methods in the code and not actually execute Solidity code. And if these kinds of contracts are considered precompiles, it messes a bit with that. At least in Geth, pretty clear distinction between what is a precompile and what is not precompiled. I don't know if there was anything else raised. Yeah.
So because people have put a lower number of contracts in their Genesis files, that should be a block to a future reservation of a precompile? Is that the basis of the argument?
Well, yeah, it's not an argument per se. It's more like, hey, this is a can of worms. We need clarity on how this should be handled.
Well, the reservation, it's not in the future. It applies to previous, like, it's not applied from a hard fork number.
So just to give a concrete example, for example, if Puppet creates a test network, notably Rinkaby and I think maybe even Gurley was created in such a way, then it initializes the first 256 accounts with one way. The reason was that if we ever start putting precompiles there, then we sort of essentially we had that issue between parity and Geth with one of the precompiles getting deleted and the whole network acting up. And then we had this little tiny hack where we just pre-created 256 accounts so that forever into the future we will have those accounts as existing, and they will never say that they don't exist. And the problem is that with this EIP, all of a sudden, all those 256 accounts get a bit more special meaning. And depending on the implementation, for example, when we retrieve the code hash, previously they returned the code hash of the empty account because the account existed, but they were empty. But as far as I know, retrieving the code hash for a precompile doesn't return empty, rather it returns all zeros or something like that. So there's something quirky in there. And I guess what Martin wanted to point out that this should be explored because it might actually hide some subtleties that that depend on client implementations to get right.
Okay, so there's some lack of clarity. If it's reserved, doesn't mean we necessarily treat it as a precompile, even if it's not assigned. That, yeah. Okay. I guess we can move this on back on ETH Magicians. We're not going to solve this on call.
Yeah, I agree.
Peter, could you write down what you said? I think it would be really useful to have it written down on the forum.
Yep.
Great, thank you.
On the forum. Yeah, not the Puppet stuff.
It might be.
It's a long thread.
Yeah, I don't think this particular example is included there.
Okay, so the next one is, let's see. We just talked about 1352, right? Yeah. So we are going to 62.9 action item, which is EIP 2045 needs further discussion. That's on particle gas cost, and that's had really good conversation recently between Dano and Paul and Martin and others. And Casey. So is there an update on that at all that anyone can kind of say based on the forum? I haven't been able to read it thoroughly.
Yeah, might.
And if not, we can wait till Casey's on. Oh, go ahead, Martin.
No, I was gonna say it would be nice to have Casey on to champion it because I really don't see why we need it. But that's just
okay. Well, yeah, we'll wait for Casey. There's enough going on for this call that we can skip it. The next action item is 62.11, discussion and inclusion of EIP 1962. And I thought we already talked about 1962 a little bit. Oh no, that's the EC arithmetic and pairings and runtime definitions by Alex Vlasov, who I think is on this call. Alex, is there an update for that, or was that the one that the bigger EIP, I think it was 2028, takes over all of that?
Well, as far as I know, at least, maybe I'm not just following it completely. There is no larger EIP which should overcome this. This one already takes over the 1829, which was.
That's right. I got it confused.
Okay. So the update is the following. In principle, it's ready, and there is also kind of the spec which is being written, much more formal than before, including the binary interface and quite a lot of edge cases. There is also a separate Telegram channel which has much, I think, most part of the discussion, not the Ismatician forum, but actually a Telegram channel. On top of this, there were mainly one major decision is whether it's necessary to make a separate implementation for a kind of alternative implementation, and this alternative implementation should be actually as performant as the one which is already available. And kind of relative to it is a question whether to actually in the next fork to give access to any arbitrary curve, or for an next fork we say that let's give 8 these curves which are most likely the most needed for developers, and we kind of enumerate them and say you can call any of them even while it will be the same code underneath, and then kind of either extend it to the larger set of curves eventually in the next fork or even between the forks, or just allow people to use anything on their own right from the next one. So those are mainly 2 points for discussion.
Yeah, to give some context and also some questions. So I saw there are 2 Telegram channels, and in one of them it was mentioned that the EAP implementation is 7,000 lines of code from what I believe is C. So that's one question if that's correct, and because my response to that is basically if we have a behemoth of 7,000 lines of codes of C, then I think we should have a second or even a third implementation and have them run fuzzing on those 2 implementations for like a month or 2 to weed out both crashes and differences, because these are really tricky things to get right.
Regarding the size of the code, I'm sorry. It really also depends how I kind of style it, but in principle, it's maximum 3,000 lines. Everything else which is in a repository is a huge amount of tests. And for every test which you have to assemble, you just have quite a lot of lines of code just to actually run it. So it's not that insane number. Regarding the fuzzing, I myself will eventually get to it, but for now, my target is to run the gas metering procedure first, and then actually start making the fuzzy tester, which is not just taking some input data and making it into some form of garbage, but actually trying to poke some specific parameters into the invalid values.
Oh, but we need to add one very important point to the discussion here. It's not C code. It's all written in safe Rust code. So we don't have even any non-safe Rust invocations except for the C expert interface, where we receive the string of input data from the caller, which we have to check for length, and then we convert it into safe code, and we only execute for safe Rust code. So we can guarantee that there's going to be no corruption of memory. No memory outside of stack is used. It's completely stateless, and it cannot panic. Like only few lines of code use constructions which could theoretically panic, like accessing some optional value. But we will replace most of them with just returning error. And at top level, there's going to be a catcher for any panic. So it cannot crash, it cannot corrupt memory, it cannot blow up memory with memory leaks.
Yeah, I would still say, I mean, that's good. It removes one class of vulnerabilities, but I still think it sounds optimistic if we have something which is today only implemented in Rust, to think that we're going to roll it out on all clients at the next hard fork without having a parallel implementation and having done differential fuzzing.
The parallel
this gives this this is kind of the question to developers directly. I mean, for now, no one has volunteered to try to make the full a replica in other programming languages such as Go or C++, for example. C++ would be much easier in this case and Go just from the language perspective. There are some efforts to make kind of Python or Sage implementations, which are of course not for production, but mainly for cross-checking between implementations, especially for kind of, at least for consistency. I mean, you just at the same test vector, you should get the same answers, basically, even while your implementations are distant and not replicas of one another. But it's more a question to developers, whether it's enough to have kind of one main reference implementation, which will provide actually the performance benefits, or it's kind of really, really necessary to try to make an alternative one in some other language, which also should give the same performance at least, which would be non-trivial if you do it in Go, for example.
I've always thought that one of the core values that Ethereum had over most other blockchains is that we celebrate having multiple implementations and having multiple clients. So to encourage people to use just one library starts to chip away at that. So I'm a little hesitant to recommend that to developers because that's one of the things that, you know, we're sure of our consensus because we do it multiple different times. I think that's one of the things that makes Ethereum valuable.
Yeah, I mean, it's more about it for now, kind of sort of, I would say 2 people who work on this. And I cannot guarantee that I will be able to provide a Go implementation. The part of the reasoning why maybe it's not actually a good idea to have multiple implementations for this particular case is that there was an error in parity implementation of ORPN, or at least how the original code by Zcash was called. There was an error in gas code in gas for the same precompile, and there is still unfixed error in Pantheon for the same precompile.
It's
and
fixed. We shipped it 2 days ago.
Okay, then sorry, I'm not following this too much, but yeah, sure. It's just that for this particular case, it may be it may worse to put as much effort on one implementation, a reference implementation, which will be kind of supported and review it, than trying to make 2 or 3 of those.
So to just to stress it, there will be a separate implementation in any case in Python or in Sage, which will be intensively used for cross checks. So there's going to be a very intense fuzzy testing with lots of different inputs where both implementations will be compared, but it just won't be an implementation which can be included in a client because it's not going to be as performant. Because we're talking about really hardcore optimizations for all these heavy arithmetic operations, which Rust is really hard to beat, and like compared to Python, it's orders of magnitude different. So we're on it. Like the question is about an implementation which is production ready, not that there will be a separate implementation with 100% compatibility requirement.
So I don't think that the argument holds that it's a good thing that there's only one implementation because it means we'll have consensus, because that means we might have an incorrect implementation as our reference implementation. And I don't think that, I think it's better to take it one step at a time and first produce a couple of implementations, then make sure that they are consensus compliant through extensive fuzzing, and then talk about including them into clients. So I think it's too optimistic to try to get this into the next hard fork because it's very complex. And one of the reasons that I think you haven't got any Go developers, I mean existing Ethereum Go developers to implement this is because this is advanced cryptography, and most of us are not cryptographers. So it's pretty hard to implement this stuff correctly.
Just a separate question about separate implementation. I mean, alternative implementations. Uh, is there a kind of hard requirement to have alternative implementation in Go, or just, for example, C is as good for this purpose?
What do you say, Peter?
I didn't say anything.
About the question if is it a hard requirement to have an implementation in Go?
It wasn't me who asked it.
What was that?
It wasn't me who asked it.
No, yeah, I'm wondering about your answer to that question.
Well, okay. So generally, calling, for example, a C method from Go is about 20 times more expensive than calling a Go method from Go. So there's definitely an overhead. Now, if that method is basically just calling a precompile and which executes some number crunching and returns that, probably number crunching outweighs the function call. So from that point, it's not, from that perspective, it's not that relevant. So including C code in Go is fairly doable. So we had previously, probably even now the SecP curve is implemented in C. So that's fine. However, including, for example, Rust code into Go, that's a problem because Go does not support, by default, building Rust. So the only way, for example, to include Rust in Geth would be to create a whole new build pipeline, which first builds the Rust library into a shared thingy, and then imports that shared library into Go as a kind of like, as a static library. And that one also brings with itself a few other potential problems where, for example, with Go, we can cross-compile to a whole lot of platforms, and Go takes care of all the figuring out which C compiler, which flags, etc. to use. Now, if we start adding Rust, since Go is unaware of Rust, it means that all of a sudden we have to maintain the cross-compilation for every single platform that the Go standard library up until now supported out of the box. So it is probably doable, but it's probably painful to do.
I mean, it's also kind of related to the case where, I mean, most likely you would also would expect the performance to be quite different between platforms in this case, while usually all the gas metering happens on one reference platform. I don't know if it's also related, and kind of this is a great feature which is available for Ethereum in principle, but this one is also kind of troubles me whether gas metering should also, for example, happen at some alternative platforms or not.
Um, I'm gonna need to table this for the moment, since we're kind of in a deeper discussion here, and we have a lot of other stuff to get to. If we could take this to the Ethereum
Okay.
Magicians forums and get
Can I add one more comment just for completeness?
Sure.
So Alex created EVMC kind of bindings to this EIP, so you can load it as a kind of EVM that supports only this single address. Yeah, I just wanted to mention that if that might be considered. I'm not sure it solved any of the problems, but this work has been finished, so it's also something you can take a look on.
Did you say that Alex or Alexi did that? And if you said Alex, which Alex?
Oh yeah, sorry, Alex Berexazi.
Okay, got it. Thank you. And thanks, Alex, and thanks both Alexes for coming on and talking about this. And yeah, we'll continue this conversation on Gitter and the Ethereum Magicians to see what we can do about the CIP.
Yeah, just to add the last part. I
Sure.
mean, sorry again. The full spec is not yet available, but it will include kind of the almost step-by-step arithmetic implementation guidance for the same purposes, for kind of people who are not deep into cryptography and never implemented it, Not, I mean, not never implemented it before, but who are not that familiar with the subject. So if it helps for Go developers to actually try to make an alternative implementation, just tell me.
Okay, thank you so much. The next action item is the Ganache spec compliance issue with Go Ethereum. Oh, it looks like I'm getting an echo problem. I'll fix that while I'm talking. So has anything been done about that? That's from like 4 meetings ago, so we might just take that off.
Yes, actually. So if you follow that link and then go to the Go Ethereum issue from that, the last comment is from Felix 3 weeks ago. So I've tried this against a couple of clients and they all return quantity encoding. I'll bring up the spec change in the next core devs call to make sure we're not tripping up anyone else, but it should be really be fixed in the spec instead. I guess Felix hasn't been present to talk about that, but yes, can we change the spec so that, what is it, the V should be a quantity in the spec?
So just to expand a bit, so the issue is that when, for example, the transaction signature is returned from the RPC, the RSV values are returned separately. And the spec, the JSON spec states that R and S are binary blobs, 32-byte blobs, and V is a value. And cryptographically, actually all 3 of them are values. So it's the spec is a bit weird. Probably somebody saw that, hey, these look like 32 bytes, so let's just make them binary. Anyway, the problem is that if you interpret them as numbers, as a quantity, then you're not allowed to have a 0 prefix, whereas if you interpret them as a binary blob, then you have to pad it to an even number of hex characters. And that this is where Geth and Ganache tripped up on each other, because Ganache assumes, essentially Ganache follows the spec and Geth follows the theory that these are numbers cryptographically. And the question was, who is at fault? And fixing either of them is trivial. We just need to decide which one to fix.
Thanks for the update, Peter. So next up, let's take off action item 58.1 because that's going to be in the cat herders domain now.
Question: what's the decision then?
Yes.
Do we fix the spec?
Oh, sorry, I didn't know that was up for a question.
Yeah, so the
I thought you said that you were figuring it out.
So the suggestion from Felix, he said he tested it against a couple of clients. I assume that means Geth and parity and something else. They all return it as a quantity, like Geth does. And the question is, can we change the spec?
Oh, okay. Let's see. And so that's a Ganache question, right?
That's a generic Ethereum RPC question.
To the node developers on the call. And I
Totally
guess
fine for me.
building on top.
What was that, Tomas?
Yeah, I say any changes here are totally fine from my perspective.
Sounds like since a lot of people use Ganache, you could go ahead and change it because that's going to be a bigger user than other people who might be using it as long as they get warning.
Yeah, let's be bold here and take a decision. I vote we can change the spec, and I don't hear any disagreement.
Okay, change the spec.
Okay, change it up.
Just a shout out to people watching. If any client is using it differently as a binary blob, please shout out on the issue or wherever so that we can see you.
Okay, we're going to change the spec. Who has the action item to do that then?
Is that a spec that's like on the wiki or something? Which spec is this? RPC?
JSON RPC on the wiki.
JSON RPC? Okay. Yeah, anyone want to go in and I guess when Go changes it, can you all just go into the wiki and change it in there?
I'll ask Felix to change it. Okay.
Sounds good. Okay. Well, we're almost done with the meeting and almost done with last week's action, or we just finished it last week's action items. So we'll run through these next ones. We did get some good discussion down for the next hard fork EIPs, some of them. So let's go ahead. I know that there's some people today who are tuning in for or who have joined the call, I should say, for EIP 2028, and I think that's related to 1962, the one about the Starkware Rust library for EC precompile or EC arithmetic and pairing calculations that Alexi's involved in. Am I conflating two things together, or is that right?
No, I think you are. Can you repeat what you just said? So Louis can.
Yeah. So basically, someone was talking about EIP 2028, that there were some people on the call today for that one.
It is me. And
Oh, wonderful.
And Eli Liben Sasson should join too. I asked him to join.
Yes, I'm here. Hi, guys.
Hey, Eli.
Hi.
So yeah, go ahead and talk about what you need to talk about there, since I know you're not on every call, and then we'll have a little discussion on that, and then we'll run to the next item. I might have to time box you on there, so just high level. Thank you.
So roughly speaking, so EIP 2028 is about the reduction of cool data gas costs, which we worked on and released yesterday a test plan with Yblock to gather more simulation data, because measuring is a effect on network about the increase of block size is limited on the actual network, and we want to hear about people's opinion on the test simulation and on the simulation plan, and also hear concern on this on CCIP.
So the number was 2028, right?
Yes.
Okay. Let me pull that one up. I'm going to post this in chat. I think, this was Alexi, Ellie, Tom, and Avuhu.
And Louis. I mean, his name would be added.
Oh, and Louis. That's right. Yeah.
So essentially, in terms of code update, it's going to be a relatively simple change, right? Reducing the parameter for gas cost from 6 to 8 to something smaller. Roughly 4x or something like that. And
what you were going to plan to reduce it to.
Well, we don't, the simulations are going to give numbers, but it will be a significant reduction. That's what, seems to be justified. Louis, maybe you want to talk about it.
Yeah, does anyone have any comments or concerns about or want to get involved in some of the things that they're working with the test simulations to come up with the exact numbers for that?
Sorry, go ahead.
Sorry. I just want to comment, because 2028 is a gas reduction, so we either want to be more careful or apply it with a conversioning, just to avoid potential backward compatibility issues.
You're saying it should be paired with account versioning, or it shouldn't? It cut out for me.
We either need to pair it with a conversioning, or we need to be some extra assessment to just make sure there is no backward compatibility issues.
And that's on transaction level, not on the contract level, so it will not touch accounts really.
Yeah, that's correct.
Oh, okay. Yeah, sorry.
It doesn't affect EVM.
And I would say that right. Also, I would say also that it's a bit incorrect to call it cold data reduction, because it only affects the gas cost of the transactions which originate from the from the contract, but from the external account, because within the contract codes there's no charge as far as I understand. Only the data that are basically included into the blocks and made their way to the to kind of to the frontier of the EVM. This is what changes. So I would say it's a reduction of the call of transaction data, not the call data. What's it called? Yeah. So it's a bit confusing, but yeah.
We agree. It's only basically the impact is an increase of block size mostly.
So just running some numbers. So currently, if we were to allow this, I mean, if there was somebody said that we could reduce it by as much as 4x. So that in theory, if we stick to the 8 million gas limit, that would allow one transaction to weigh half a megabyte at max.
Yes.
Or a block, I mean.
A block would be half a megabyte, yes.
Yes, okay. That probably we want to, I have two issues. One of them is the state growth, or the chain growth. So it would be nice to perhaps see how fast the chain is growing, how large the blocks are currently, and maybe we could investigate.
I can comment on this. So the average, so first of all, currently the average size of the block is around 25 kilobytes, and it depends on what we are looking for. Do we want the chain growth as a full node or an archive node? And also as a part of the state's growth, in our case, we claim that the increasing the capability of sending more transmission will actually reduce the state growth.
So I would, so this one affects both archive nodes and full nodes because all of them has to store the chain. So that's
no,
not that.
Full node would not. Full node not necessarily. Archive node will grow fast. Will grow faster, but a full node will not share necessarily store more information, much more.
Well, but since you make it 4 times cheaper to push transaction data into a full node, you potentially grow it 4 times faster.
No. First of all, the growth is not the block size is only a quarter of the current growth, and so it's not. It's more like roughly it's more like the block size impact for today for 30% or 40%. I don't remember exact numbers, but of the actual size of a block. But like the data itself roughly represents 30%, and so increasing by 4 will only roughly grow by half the storage.
Okay, that's fine. So I just wanted to bring it up that it's an interesting thing to explore. And the other interesting thing, which is maybe a bit more sensitive, is transaction propagation. Because so currently I know that GET has a limit on the transactions, and they can only be 24 kilobytes in size to be propagated, or 25.
32 kilobytes, and we pushed a patch on it because parity allow it to happen. It's not a consensus rule.
I know it's not a consensus rule, but the point is that if unless all major clients kind of support the same limits, one of them will filter out the transactions. So if they propagate much less. But so my point that I wanted to raise is that yes, it is of course doable to raise the limits, but it does have 2 catches. One of them is it's always a denial of service possibility, so we need to be careful. And the other is that from a network bandwidth perspective, transaction propagation can all of a sudden take up a lot more bandwidth. So for example, if we allow a single transaction to weigh half a megabyte, that's a non-trivial amount of data to shuffle through the network, especially since nodes kind of propagate this logarithmically. So essentially, if you have 25 peers, then I don't know, you will actually propagate the same transaction across your internet connection, 4 or 5 times. So that's already 2 to 2.5 megabyte of data just for a single transaction. So what I'm actually saying is that we do need to be careful about the network traffic, because we might end up creating transactions that just clog the whole network.
we agree on that, and that's exactly the reason why we are making simulation with white block. It's literally the test we're going to run this week. Started a bit less. It started this week and continue next week, and to also to actually point an element on that part is we looked also at the block, the historical anchor rate versus block size on Ethereum, and since the update of parity, there is a very, very weak correlation between block size and anchor rate, and on existing blocks. So the range of existing blocks range between 15k kilobytes to 35, and there is a very weak correlation on anchor rate. I can share the graph if you want.
Well, yeah, but so honestly, 25 or 35 kilobytes is the same thing, but we're talking about an order of magnitude increase here.
But we will, even increasing the block size, we will not increase. People will not send blocks of the size of the entire block. Like, it won't happen today. No one is sending blocks over 30 or 40 kilobytes.
Well, my point is not general use case. Of course, people won't send a transaction with 0.5 megabyte worth of data, but if the protocol allows it, it means that somebody could. So if I send 3 of those transactions and the entire network dies, then it's pretty much a denial of service sector. So this is my main concern here.
It is also our main concern. I would just argue over it by knowing, by pointing the fact that 0 byte are priced at 4 bytes, and you could make very custom.
But the network traffic is compressed, so 0 bytes actually compressed.
Yeah, Snappy doesn't care about what kind of byte. It's pattern matching. It only.
Yeah, but I can create a 0.5 megabyte block which doesn't compress at all to attack.
But it's that made to go to the worst case scenario on Snappy and makes blocks that are actually bigger than 120 today, using the 0 byte element. But the point is here. The first of all, the point is that we have today 2 pricing very different, 17 times different from 0 byte and non-0 byte. And to be honest, I worked on it and I don't understand why. And the second part is we could today create custom blocks and custom transactions that would go over the 120 and would still be potentially a problem, but we are not there. And I think that raising the block size should be made in a very controlled manner, but shouldn't be too much of an issue as regards to what the network is already doing today.
Hi, so Eli here. I just want to say that, so Peter, your comments are well received. That's exactly why we want to do the simulations and see what the data points to. We'll be more informed. We'll be sharing the data hopefully early next week once we see it, and we hope we all want to take a conservative view, but I think there's a wide consensus for a very long time among developers that call data gas cost is way too high, and this has a lot of other bad effects that we already notice today that are causing serious problems in the network, most notably that everything goes to storage, other problems. So by actually doing this, you might actually be making the system more secure, but of course we need to address these points. As Louis said, we already pushed a patch to remove this sort of artificial limit on Geth, and we'll make sure that this happens so that there's no disparity between parity and Geth and the other implementations, and then everyone can accept larger transactions. And we'll simulate and measure, and we'll be working very cautiously. We don't want to, we only want to improve stuff, not cause trouble.
Okay, thank you all so much for giving updates on that, and I'm posting a link to the Magician's Forum where people can probably, I'm guessing, follow updates on this, and that's where you'll be posting some of them.
And Hudson, just for last all core devs, Rick and I were talking about 1559, the fee market change, and that we were in talks with a group that was also looking to do tests for EIPs, and perhaps that part of the the DevOps that Ethereum has could be extended to some of these groups, and this is the group. So,
oh, great, cool. And from the conversation last time, I did talk to the DevOps team a little bit, just like introductory about maybe having foundation resources deployed to help test for EIPs, whether that be server time or different like nodes getting spun up or things like that. Probably things that are much beyond that and beyond what I even understand how testing would work. Getting that under the foundations umbrella, and the initial conversations were good. We basically said, let's look into this more over time and see what the requirements are and see how we can help. So nothing concrete there yet, but that's just an update to our conversations from last time. So thanks so much for coming on and talking about that, y'all. And um, let's move on to the next thing. We have a few minutes left.
Hudson, if you mentioned testing, I could make my update right now.
Sure. Do you have a quick test update? What is it?
Yeah, the main update I think is that Get is now support retested, and it is possible to generate tests for EAP implementation with a Get client. Get now could generate state tests and blockchain tests. And we are planning to make workshop in Berlin this August for the test teams and people who might work on test implementation for EAP that you mentioned.
Oh, that's great. It'll help people be able to make tests more easily.
Can I add to that?
Yeah, sure, Martin. What's
So
up?
there's an idea that I floated in the old core dev channel and in the testing channel, and it exists now in the form of a PR in Geth, but it's not merged yet. The ability to run state tests where the fork identifier is, for example, Constantinople plus 1884. So we can have state tests which says the base fork and a particular EAP or a couple of EAPs. That means that people could start producing state tests right now and not put Istanbul in because we don't know how Istanbul eventually will be defined. They can instead put Constantinople plus EAP number. And that could make it easier for us all to get tests ready early on if the other nodes also implement these kinds of test harnesses. That's it.
Great. Thank you. For the next item, I actually had a question that I'm going to bring up from the comments to Alexi. Alexi, as far as all the state rent stuff goes, is there any, realistically, the question is in the comments, realistically, do you think it is worth pursuing any of the state rent proposals for Istanbul if we stick to the October release deadline?
Okay, so there's about 5 of the IPs that I've written, and then I didn't hope that they all going to go. We will have the time to prepare them all. So at the moment we have done the implementation of one of them, which is the 2027, which is basically introducing a storage size accounting. But what I've noticed is that it's actually kind of conflicting with the current implementation of account versioning, which is basically adding another field into the account. So unless we are basically generalize it somehow, it will be basically because the account version is the fifth field and the storage size is the fifth field as well. So they have to be reworked, or we have to find some sort of general way of doing it. But for the others, I mean, we could do the implementation, but with the current state of the Istanbul preparation, I don't think that it will be, because basically it became a focal point for basically anything that the focal point for anything that people want to change in Ethereum. And I think somebody pointed out that initial plan for like when we were doing it from in the DEFCON 4 and in back in Stanford is actually the initial plan was to basically to treat it as an emergency measures to basically stop the chain from dying. But now I can see that it became more as a focal point for anything that people would like to change. And in this situation, I would say that it's probably unrealistic that a lot of progress in state rent will be done because of the kind of a lot of conflicting issues and a lot of. So basically, what I'm saying is that I don't think we will be able to push a lot of the things in Istanbul, simply because it requires a bit more work, and also because there's a lot of other things on the way. So yeah, so I would say that's
Okay.
more pessimistic at the moment.
Just want to give an update on the account field. So I did an update to the account version in EIP last week, and right now it should be compatible with any additional account fields. So how we do this is pretty simple. We just first parse the fixed field to check whether it exists. If it exists, we parse it as version, and then we interpreted any additional account fields as defined by that version. So in that case, it can be compatible with the state run that account field EIP.
Okay. Sounds good. Was that it, Alexian Way?
Yeah. So, and the other still major part of the work is to come up with a specification and some more data about the stateless client and semi-stateless client, which is still my focus. But unfortunately, there was a lot of stuff in between. But I'm still looking to do that. So to have a specification so that if people want, they can implement in a compatible way in other, in any kind of client. I'm trying to avoid the word client, but just anyway.
Yeah.
Anyway, so that's basically it. So we still the work is still going, but it's I'm not very worried about not some of the stuff not getting in Istanbul, because essentially that, if I start getting worried, then there's no good gonna come out of it. So I'm just going to be continuing what I'm doing, and I understand the realities of our situation. So that's basically it.
Okay.
Lexi, so I think the 2027 is the one that conflicted with 1884 with the increase of S store.
Oh, I think it was a different one. So the thing about what you wanted to discuss today, I think, Martin, is your proposal of raising the cost of S load and balance, which was conflicting with my other AP, which I don't think it will be ready for Istanbul. So I would basically say, just ignore it for now. So the other, I don't remember the number now. I think it was like 2835 or 34, whatever. So I think if you want to propose I think you already did, the increase of S store and balance, just go for it, because
S-load and balance.
S load, yes, and then just go for it, because I don't think I will be in a position to basically to offer the alternative for the next update, for the next fork.
Yeah, I see.
Okay.
One question here: does it mean that there'll be no chance of getting Ethereum 1.x within 18 months, or is it just that it will be 18 months but slightly slower than expected before?
Basically, it depends on how the whole Ethereum 1x kind of unfolds, because as I mentioned, that it's sort of the meaning of this has been changing over the year, over the course of the year. As I said, in the beginning it was conceived as basically like a sort of set of emergency measures, and this is where we created initial groups. But then over up to basically in April, it became clear that it's became a focal point for basically anything that goes. And I don't know if we want to rethink it and then bring it back to the minimalistic set, then we should be able to do something like within 18 months. But and also it depends on how we're doing with the testing, and we ability to deliver multiple update changes at once. And I also, as Dmitry mentioned, we did some work on that with the Go Ethereum, but there's lots of more work required. And I myself, even with the people who help me, I don't know how long it's going to take to prepare both state rent and trying to change the process to accommodate all the things that people want to put in, because I said it became quite a large thing. So that's, I don't know. Basically, the answer is I don't know. I have to see what happens with Istanbul first.
Yeah, Istanbul is going to be a big deciding factor in what 1x turns out to be, but it's kind of like an all-encompassing thing now that includes process changes with how decisions are made, what EIPs are going in, between now and what is quote ETH 2.0, and also the mitigation efforts Alexei mentioned towards stuff like state bloat and things like that.
Yeah, my take is we need to reject more suggested EAPs and not just table discussions for later.
That's a good idea. Yeah. So we should start doing proposals to reject EAPs outright, especially if they're slower on the uptake, as far as getting them ready by the time they need to be ready.
On that, a
So
note on
yeah,
that, there's only 10 EIPs that have reference implementations out of the 34.
we should have like a chopping block session next time where we like really get rid of some.
Well, the soft deadline, according to AFRI's original schedule for client implementations, was next week's, which is why I proposed that anything that didn't get accepted today should probably just be chopped and pushed off. So there was a little bit of pushback there, but I think we should definitely do it in the next meeting. If it's not in the next meeting, it's not in.
And I think that that'll be a lot easier to do if we can be confident that the next hard fork comes soon. So if we're really buying into that schedule.
Yeah. Are we buying into that schedule? What does everyone think? Or is there anyone who wants to say, I do not buy into the schedule or I want an alternative?
I mean, I said before that I don't buy in the schedule, but it's just my personal thing, and this is the way for me to stop worrying about stuff. So, but
yeah.
Is that because you wanted 4-month cadence instead of 6-month, or are there deeper schedule issues?
it's just that I'm still hoping that we could increase the cadence, and then we can do more changes, but the smaller ones. That's but I don't know how it's gonna play. So
I think we could accommodate that if we make out space and say this fork is just for these issues. But that's, we're 6 minutes over, so we're not going to solve this today. But I would support that.
We can make a whole goal for the next meeting to be, cut out, or basically make sure that anything that's going to be accepted is accepted by next meeting.
Let's do it.
Anyone else have comments on that?
No.
Dano.
I have more like a formal question from a person who actually does implementation. What do you call the kind of the reference implementation in the sense of completeness?
That's a good question. Who has an answer?
Sorry, the question was, what do you call?
Yeah, so I mean, you like a reference implementation can be called a few different parts. One is kind of the first reference implementation plus some gas metering, initial tests, like what's in the spec in principle. Also, it can be you can call the reference implementation a kind of full set of separate implementations in all different clients. And this is actually
No,
important
I think a reference implementation is just an implementation in a client which show to other node implementers, okay, so how do we integrate this and what parts need to be touched? Is it, I mean, for some of them, it's just change the constant in a gas table or add a precompile, some test cases, and you're done. And for other ones, it's a lot more complex. You have to change the something in the block envelope or whatever. So I would say a full embedding of the EAP inside a node. That would be my take.
When I was writing, so to answer this question my way, sorry for the interruption. So when I was writing this blog post about the process of ETH1X, so my definition of reference implementation was that the implementation which is able to generate the conformance tests is the reference implementation. And so far, we only had Aleph as the reference implementation because all the tests would be generated off that. But as the Dmitry mentioned now, Geth is also could be used to produce a reference implementation because you can generate conformance tests from it.
Hey, Wei, if you're able to speak for the parity team on this, is there a way that we can get the retest I think it's called retest
Yeah.
those changes into parity so that we can do the same thing with them that we're doing with Geth and Aleph?
Is that the one with like you keep plugging in RPC methods and there's an external program that calls those RPC methods to run the test or something like that?
Is that what it is, Dimitri?
Yes. Also, we did this implementation with Go Ethereum as a research project, and maybe RPC is not the best solution. Alexei mentioned that he has idea how to improve the protocol using some other communication channel, dev P2P or lib P2P, some of this.
I think, yeah, if Wei, I'm going to, if you want, we can talk about it offline. I can explain you what we did in Go Ethereum, and we can probably transplant it to parity. So
yeah, I think we need more discussion. Like,
yeah, sure.
I think right now, like for parity, we are still like we have some issues implementing a test protocol using RPC methods because that would require like a really large amount refactoring from our current analysis. But we can talk about this more to see if there's other ways.
Well, that
Okay, so go
that
ahead.
was initially what Go Ethereum was also saying, but when we just did it, so
yeah, sure. So
So next time will be let's decide on
Really
all the.
quickly on the decision, a hybrid suggestion. If we say we cut all of the EIPs that don't have reference implementations by default, and other ones need to be applied, like apply for specifically, that would cut 2/3 of them. So that's, I would say, a good kind of in between. The ones without reference implementations are automatically on the chopping block, and if they don't come to the core devs with something that time, then that's already 2/3 of them cut.
Nice.
A quick question on the implementation. It was brought up that there are many EIPs which propose a gas cost change or like a simple change. And many of those didn't receive any attention from a lot of clients yet. Does it make sense to make the change in one of the clients, and will that get a review faster in that case?
I felt like for that category of EIP, benchmarking was more important than a reference implementation. Am I wrong?
So as one example is the the repricing from Martin.
I think the problem here, actually, there's no problem here. Just we assume that they are so simple that I need a discussion, and maybe it will be good to formally confirm it that we all think like that, because some of the APs on the list, they seem very, very simple, and everyone assumes they're trivial and so on.
Yeah.
Changing a constant probably doesn't need a reference implementation, so it may need benchmarks and justification.
Actually,
but if it's more than like event 1283.
So 1884 does have a reference implementation in a PR. Thing just recent development is that AXIC pointed out that Xcode hash should get the same increase from 400 to 700 as balance. It was introduced in Constantinople, Xcode hash, at 400 with the reasoning that it should be the same as balance. So I plan to update, if it's possible to update the finalized the repricing to also increase Xcode hash from 400 to 700, just like balance. It's a bit more than trivial though, because it also introduced self-balance, at very cheap. So yeah, so it's not as trivial as only repricing, but it's still pretty damn trivial.
And that's 1884, right?
That's 1884.
Okay. So, James, you're an idea of basically cutting out all the ones that don't have reference implementations. Now that's kind of being challenged to say some of these are so trivial they don't really need one. Is that where we're at?
That's the case, and they bring that up, and then it's resolved.
Okay. Yeah, that's good. So let's just say nothing's officially cut tonight, but everything's on the chopping block if it doesn't have a reference implementation and if you don't attend the meeting to defend yourself and say this is why it doesn't need one. Let's do that. And then for the 10 that have reference implementations, we'll try to discuss that as much as possible offline, and then during the meeting try to have more focused conversation on it.
Do we need to carve out?
Sound good, everybody?
Yeah. Do we need to carve out time to discuss what the next forks would look like afterwards? Just as a scheduling issue after the meeting or during that meeting?
We'll see how the meeting goes. I guess if we have time, I'd love to discuss it, but if we don't, we'll have to switch it to a magician's thread.
Sounds fair.
Yeah. Okay. And we had to skip some items today. Sorry, everybody. But if you could go to the agenda and click on them and comment on them, especially the EIP 2124, since that's not a Istanbul EIP, but a networking EIP that Felix and Peter from the Go team want to bring up. Go ahead and take a look at that, and we can kind of give an up or down next time.
So just one sentence about that EIP. It doesn't touch consensus. It doesn't even enable anything yet on the network. It rather just defines the data structure. And I guess most people don't really care. The question is if anyone sees anything obviously wrong with it or has some obvious issue with it, then just please write it down. I don't think it's worth too much time to think about it because it's just a no-brainer definition of something that might be useful.
Yep. Lastly, is there anyone that I just skipped out on their EIP this time? I think I skipped 1962, which was the Matter Labs thing. Or did we talk about that? We talked about so many.
We talked about it.
We talked about. Yep, that's right. It was Alex's thing. Sorry. Yeah, we talked about so much EC arithmetic stuff or whatever today, pre-compile stuff that I was head was spinning. And then EIP 2025. That one is block rewards proposal for ETH funding for 1x. I think other than that, we got everything done. If you want to talk about that real quick, I think James, right? You had that on the table. If you want to just talk about that while everyone's still on, and then we'll sign off. Or you can wait till next time. It's up to you. Hello, James. Can you hear me? You're on mute if you are talking.
Of course, I was muted. Yeah, we can talk about it next time.
All right, sounds great. All right, well, thanks for staying over, everyone, and we will talk to you all in 2 weeks minus 8 hours from this time, and then we'll need to be careful keeping up with when we subtract 8 hours, not to go back in time, like a day, and to actually keep it between Thursday and Friday. All right. All right, thanks, everybody. Have a great weekend. Cheers.
Thank you. Bye.
Thank you. Bye-bye.
Cheers.
Thanks, bye.
Yeah, thank you.
Bye-bye.